Wow. Welcome to this tutorial class for Jamb 2018. I am Mr. Jeremiah Ajali. Um, I am a human resource developer. What it simply means is that I develop people, I teach, I want to take out some time to prepare students writing Jamb. I can actually teach maths, physics, and chemistry effectively, but I would like to start with mathematics for 2018 and see how it goes. Basically, maths, you need to be swift, you need to be accurate, you need to have all the formulas in mathematics right before you. You have to just see it and just get to it because you don't have all the time to dilly down in Jam. Okay. Um, These are the topics, the first 10 topics I'll be taking. After this, I'll take the next 10. So we'll be taking indices and logarithms, we'll be taking sort, we'll be taking variation, number 4 quadratic equations, polynomials, sequence, inequalities, binary operations, change of subject formula, and partial fractions. All these are wonderful topics. I'll be taking them, breaking them to the simplest form so you can understand them. And I'll be giving questions at the end of the day so you can also practice. Please, 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 you have your gadgets with you. As you watch the video, use the pause button. If there is something you don't understand, rewind, pause, replay, solve along. Have your pen and your book around, to solve along. If you see a question, I bring a question for us to consider. You can pause that question and first give it a try before you go through the video to see how it went. At the end of this video, I'll be telling you how to follow me so you can have better understanding as we proceed on my various social networks on Twitter, Instagram, Facebook, and also I have an online discussion class where we discuss as students, various students, 2019 students discuss about various subjects. Over 8 subjects being discussed there. I would like you to also join that discussion, but I'll say that at the end of this video. Okay. Now, before we proceed, I would like you to make these declarations after me. Say, as I study today, I commit my ways to the Lord. My plans are established. I am blessed. My memory is blessed. Jesus Christ is Lord and Savior in my life. I have wisdom and understanding from Him. Amen. Okay, so let's proceed. Let's take the first topic there, and that's indices and logarithm. Okay. Now I know this is about the fundamentals, but in Jam you need to be very thorough to hit it hard. My target is that you should aim at 300 and above this Jam. Yes, that's my target. You should get 300 and above in this 2018 Jam. Okay, if you have an expression straight to business, you have an expression 6a raised to power 5. 6 here is called the coefficient. It's called the coefficient. A is called the base. Okay. 5 is called the index, also called the exponent. Index, where the word indices is from. Okay. Now the 10 laws of indices. If you can understand these laws, you can deal with indices very well. Okay, law 1, a raised to power m times a raised to power n, same base, you take one base. Because this is times, you have to add the powers m plus n, e.g. 2 raised to power 3 times 2 raised to power 4, 8, take one base, 2 times, add the powers, 3 plus 4, and that's 7, so 2 raised to power 7. Number 2, a raised to power m divided by a raised to power n. Take one base still, since this is dividing, minus m minus n, e.g. 2 raised to power 5 divided by 2 raised to power 2 is going to give us 2 raised to power 5 minus 2, and that is 2 raised to power 3. Okay, number 3, anything raised to power 0 is 1. Anything raised to power 0. 100 raised to power 0, 2 raised to power 0 is 1. Number 4, a raised to power minus 1 is 1 over a. Because of this minus here, you have 1 over. Because of this minus at the index, at the power, you have 1 over. E.g., 2 raised to power minus 1 is 1 over 2. Hope you understand. Number 5, a raised to power minus n is 1 over a raised to power n. Because of this minus, you have 1 over. When you have minus at the powers, you have 1 over. You have 1 over. Take note. E.g., 2 raised to power minus 3 is 1 over 2 raised to power 3, and that is 1 over 8. Number 6, a raised to power m then raised to power n is a. The powers will multiply m times n to give you a m n. E.g., a raised to power 2 raised to power 3 is a. You multiply the powers, give you 6. Number 7, a raised to power 1 over n is the nth root of a. E.g., 4 raised to power 1 over 2 is the nth root. Here n is 2, so the square root of 4, and that is 2. Or 8 raised to power 1 over 3 is the nth root, and that is also 2. That is 2. That is 2 there. Number 8, law 8 says a raised to power m over n is the nth root of a raised to power m, or a raised to power m, a raised to power m, the nth root of that. Any of them, both of them, it's both correct for that expression. E.g., 8 raised to power 2 over 3 is the cube root of 8 raised to power 2, which is cube root of 8 is 2, 2 raised to power 2, and that's 4. Or using this is going to be the cube root of 8 raised to power 2, and that's the cube root of 64, and the cube root of 64 is 4. Number 9, a times b raised to power m is a raised to power m times b raised to power m. You can split this power into a and b. E.g., 2 times 3 raised to power 4 is 2 raised to power 4 times 3 raised to power 4. If you do this and do this, you get the same thing. Okay. Number 10, the 10th law. Number 10 is a over b raised to power m. Now this is divide. A divided by b. You can take this power to a and also take it to b. A raised to power m over b raised to power m. E.g., 2 over 3 raised to power 4 is 2 raised to power 4 over 3 raised to power 4. Okay. Now those are the laws. Now when you know the laws, the next thing is to apply the laws to questions. So let's take questions. Question 1. Questions. The first of them says evaluate 8 raised to power 1 over 3 times 5 raised to power 2 over 3 over 10 raised to power 2 over 3. Now if you look carefully, most of the questions I'll be giving here are Jamb questions, UTME questions, and so on, related to you. I don't have time to begin to state the year, but this one is from 1988, long ago, but it's still good. Okay, now if you look carefully at this question, you see that this is 5, this is 8. In 8 you have 2, because 2 raised by 3 is 8, and in 10 you have 2 and 5. So you break this such that you have 2 5 2 5 here. Okay, so this gives us 8 is 2 raised to power 3 times 1 over 3 times 5 raised to power 2 over 3 over 10 is 2 times 5 raised to power 2 over 3. Okay, now 3 here cancels this 3 to give you 2 raised to power 1, which is 2. times 5 raised to the power 2 over 3 over. Now, you remember the ninth law, we can actually take this to be 2 raised to the power 2 over 3 times 5 raised to the power 2 over 3. These powers can go in. Okay, so if I combine the 2's and I look at the 5's, the base of 5, you see that this is same as this. So you'll be left with 2 divided by 2 raised to the power 2 over 3, and that is 2 divided by 2 raised to the power 2 over 3. Don't forget 2 is something as 2 raised to the power 1. So when you have divide and you have same base, you subtract. So this is going to give us 2 divide 1 minus 2 over 3. 1 minus that is 2 raised to the power 1 over 3, and that is the cube root of 2. Okay, number 2, simplify the cube root of 64 r raised to the power minus 6 raised to the power 1 over 2. Okay, this is same thing as 64 r raised to the power minus 6 raised to the power 1 over 2. Cube root is times 1 over 3. Okay, cube root times 1 over 3. Now this gives us 64 r raised to the power minus 6. This time this gives you 1 over 6. Now if you look critically, 6, there's 6 here. 64 is 2 raised to the power 6, so we'll break that down to be 2 raised to the power 6 times r raised to the power minus 6 raised to the power 1 over 6. 1 over 6 can go into this power and this power, so it's going to give us 2. 6 times 1 over 6 is 1 times minus 6 times 1 over 6 is minus 1. So that is 2 times r raised to the power minus 1 is 1 over r. So this is 2 over r. Okay. Number 3. Simplify square root. This is very interesting. I still remember the first time I saw this question, it was very, very interesting. Square root 71 r raised to the power 4, square root 100 r raised to the power 8. Now this outermost square root covers these two, then this covers this. So take note. So you start with this innermost one. Square root of 100 r raised to the power 8 is same thing as 100 r raised to the power 8 raised to the power 1 over 2, because square root is 1 over raised to the power 1 over 2. Okay, so you take this to have a power of 2, so it's going to give you 10 raised to the power 2, because 100 is 10 raised to the power 2 times r raised to the power 8 raised to the power 1 over 2. Okay, these two can now go in. 1 over 2 times this cancels, so it's going to give us 10 times 8 times 1 over 2 gives us 4. Okay, so that's 10 r raised to the power 4. So we'll write that to give us 160 r squared plus square root 71 r raised to the power 4 plus, we have simplified this and we got 10 r raised to the power 4. R raised to the power 4, r raised to the power 4 we can add, so that gives us square root 160 r squared plus 71 plus 10 gives us 81 r raised to the power 4, and that's in the square root. So we have to simplify the square root now. Square root of 81 r raised to the power 4 is 81 r raised to the power 4 raised to the power 1 over 2. 81 is 9 raised to the power 2 times r raised to the power 4 raised to the power 1 over 2. 1 over 2 times 2, this goes in to give you 9 times 4 times 1 over 2 gives you 2. So r squared. So this is 9 r squared. So this expression is 9 r squared. Let's put it there. So it's going to be square root of 160 r raised to the power 2 plus this is 9 r squared. We can now add this to give us square root of 169 r squared, because r squared you can add, and this is 13 squared times r squared raised to the power 1 over 2. 1 over 2 times this gives you 13, multiplying the powers, 2 times this gives you r, and that's 13 r. Quite interesting. Okay, number 4. Evaluate 81 raised to the power 3 over 4 minus 27 raised to power 1 over 3 over 3 times 2 raised to power 3. If you look critically, you can raise this to, you can take this to base 3, 3 raised to power something, and this also 3 raised to power something. So you do that. 81 is 3 raised to power 4 raised to power 3 over 4, minus 27 is 3 raised to power 3 raised to power 1 over 3 over 3 times um 2 raised to power 3. So this 4 times this, it cancels to give you 2 raised to power 3, minus this times this, it cancels to give you 3 over 3 times 2 raised to power 3. 2 raised to power 3 is 27, minus 3 over 3 times 2 raised to power 3 is 8. So that gives us 24 over 24, and that's 1. Okay, number 5. We're told to evaluate 343 raised to power 1 over 3 times 0.14 raised to power minus 1 times 25 raised to power minus 1 over 2. Now, you have to see within this question what they're trying to make you see. 25 is 5 raised to power 2. Here, you have 7 and you have 5, because this is 14 over 100, and here this is 7 raised to power 7 raised to power 3, right? Yeah, 7 raised to power 3 is 343. Okay, so we'll take this to be 7 raised to power 3 raised to power 1 over 3 times this is 14 over 100 raised to power minus 1 times this is 1 over 25 raised to power 1 over 2, 1 over because of this minus here. Okay, so this is, if you multiply 3 and this is going to give you 7 times, because of this minus, it will be 1 over this, and if I do 1 over this, it's going to flip, times 1 over square root of 25. Okay, and that's 7 times 100 over 14 times 1 over 5. Okay, 7 here 1, 7 here 2, and that is 100 over 10, and that is 10. Okay, easy, right? Okay, so this let's go to the 6th question. I hope to cover enough ground before this video rounds up. Each video will take about an hour, so you should expect that. Number 7, or is it number 6? Okay, number 6 is saying that we should find the value of 32 over 81 x raised to the power 3 minus 64 over 27 x raised to the power 2 minus 81 over 16 x raised to the power minus 3 when x is minus 3 over 4. So when x is minus 3 over 4, what is this expression? That's what they're asking. So we just need to take anywhere we see s, we put minus 3 over 4, as simple as that. So this is 32 over 81 times s is minus 3 over 4 raised to power 3, which is this, minus 64 over 27 times x squared. X now is minus 3 over 4 raised to power 2 minus 81 over 16 times x is minus 3 over 4 raised to power minus 3. Okay, so let's break it down. This is 32 over 81 times 9, and when you have a negative function raised to power an odd number, it's always giving negative. It's always giving negative. What I mean is minus 2 raised to power 5 always give a negative answer to minus 32, but minus 2 raised to power 4, if this is even, it will give you a positive answer, and this is 16. That's a simple trick you should know. So this will be negative still. 3 raised to power 3 is 27. 4 raised to power 3 is 64. Minus, take note these together, 64 over 27. Okay, times, now this will be positive because it's raised to power an even number here. So 3 squared is 9 over 16, okay, minus 81 over 16 times. Now because of this raised to power minus here, this will now be 1 over this. 1 over this means this should flip, which is 4 over 3 minus, of course, minus 4 over 3. It flips because of this minus here, raised to power 3. So this minus is 1 over, if you have 1 over this guy has to flip, okay. So this gives us 32 over 81 times minus 27 over 64. We'll soon start cancelling. Just want to deal with this side. 64 27 times 9 over 16 minus, okay, 81 over 16 times, now this is raised to power an odd number, so this must be a negative answer, minus 4 raised to power 3 is 64 over 3 raised to power 3 is 27. Okay, so we can start cancelling now. You see 32 here 1, 32 here 2, 27 here 1, 27 here 3. There's a minus here, so that's 1 over 3 minus, okay, 9 here 1, 9 here 3, 16 here 1, 16 here 4, and that is 4 times 1, 4 over 3 minus 16 here 1, 16 here 4, this is 27, 3 raised to power 3, 27, 27 here 1, 27 here 3, so that is 3 times minus 4 is minus 12, yes. So this gives us 1 over 3 minus 4 over 3 minus gives us plus 12. Okay, we'll take LCM. Did we make a mistake? 3 times 2, we forgot 3 times 2. 3 times 2 is 6. This is supposed to be 6. Sorry about that. Okay, 3 times 2 is 6. So LCM here is 6. 6 into 6, 1. 1 times that 1 minus this into this 2. 2 times is 8. Plus this over 1. 1 into this is 6 times that. That's 72. And that gives us 63 over 6. And that is 10 whole number 3 over 6, and that is 10 whole number 1 over 2. So presently this is a jam question, so it means we are in place. Okay, next question. It says simplify 0.2 raised to power 3 times 8 over 0.4 raised to power 2. Okay, you have to take these two fractions, which is 2 over 10 raised to power 3 times 8, and this is 4 over 10 raised to power 2. You can cancel some here. That's 2 here 1, 2 here 5 raised to power 3 times 8, 2 here 2, 2 here 5 raised to power 2. Okay, now this is 1 over 5 raised to power 3, 1 to 5. 1 raised to power 3 is of course 1 times 8 divided by 2 raised to power 2 is 4, 5 raised to power 2 is 25. So that's 1 over 1 to 5 times 8. Take this up, is going to give you, it's going to flip because this is divide. When you take it here, changing it to times, this guy flips, 25 over 4. Okay, so 25 here 1, 25 here 5, 4 here 1, 4 here 2. That gives us 2 over 5, which is 0.4. Okay, number 8. Simplify 3 times root 3 raised to power 2 over 3 plus 27 raised to power 2 over 3 times 9 raised to power minus 1 over 2. Okay, now this is times, so this is same thing as 3 raised to power 2 over 3 times root 3 raised to power 2 over 3, because this is times, we can give that the powers, plus cube root of 27 raised to power 2 times 1 over 9 raised to power 1 over 2. 1 over, because of this negative, of course, So this is 3 raised to power 2 over 3. This is 3 raised to power 1 over 3 times 2 over 3. I'm sorry, 1 over 2 square 1 over 2, okay, plus the cube root of 27 is 3 squared times this is square root of 9, and that is 3. Okay, so this is 3 raised to power 2 over 3 times 3 raised to power, if you multiply this cancels this, 1 over 3, okay, plus this is 9 times 1 over 3. Wow, this here 3, so that's 3. Times same base, take one base, add the powers. 2/3 plus 1/3 is 1, so that gives us 3 plus 3, and that's 6. Interesting. Okay, next question says if 18 raised to power 2 over 3 times 12 raised to power 1 over 3 is equal to 2 raised to power m times 3 raised to power n, we should find the value for m plus n. Should find the value for m plus n. Okay, so if you look critically, they want you to take these two half bases of 2 and 3, combine them, compare the powers to m and n. So when you get m and m, add m and n. So inside 18 you have 2 times 9, which is 18 raised to power 2 over 3. Inside 12 you have 4 times 3 raised to power 1 over 3 is equal to, of course, this. So this is 2 raised to power 2 over 3 times 9 raised to power 2 over 3, okay, times 4 raised to power 1 over 3 times 3 raised to power 1 over 3 is equal to this. Okay, this is 2 raised to power 2 over 3 times 9 is 3 raised to power 2 times 2 over 3. 4 is 2 raised to power 2 times 1 over 3. 3 raised to power 1 over 3 is equal to, okay, this is 2 raised to power 2 over 3 times 3 raised to power, this times is equal to 4 over 3 times, please repeat after me as I follow the process. Mathematics is very interactive. You need to interact with it, talk to it for you to understand what you are doing there. So please follow me, say whatsoever is happening here. As you say it, it gets into your head better. So this is 2 raised to power 2 over 3 times 3 raised to power 1 over 3. Okay, so we take the 2's together to give us 2 raised to power 2 over 3 times 2 raised to power 2 over 3. We take the 3's together to give us times 3 raised to power 4 over 3 times 3 raised to power 1 over 3. Okay, now you take one base, 4 times you add, so you add is going to give you 4 over 3 times 3 raised to power, you take one base, now you add this is 1 whole number 1 over 3 plus this will give you 1 whole number 2 over 3, which is 5 over 3. So this is 2 raised to power 4 over 3 times 3 raised to power 5 over 3 is equal to this guy, 2 raised to power m times 3 raised to power n. So if you compare, you see that this is m and this is n. Okay, if you compare, you see that m is 4 over 3 and n is 5 over 3. So m plus n is simply 4 over 3 plus 5 over 3. Okay, LCM is 3, 4 plus 5, 9 over 3, and that's 3. So the answer is simply 3. Okay, now you have to watch these videos over and over, solve again and again, so it becomes second nature to you. Okay, the next question says we should simplify the cube root 64 a raised to power 3 raised to power minus 1. Okay, so this is the same as 64 is 2 raised to power 6 times a raised to power 3 raised to power 1 over 3 times minus 1. Okay, of course, minus 1 is 1 over, but let's proceed. This is same thing as this 3 goes in here. 6 times 1 over 3 is going to give you 2 raised to power 2 times a, because 3 times this, 3 cancels this, and I'm left with minus 1, which is 4a raised by minus 1, which is 1 over 4a. Okay, I think this should be number 11. Number 12 says we should simplify 27 raised to power minus 2 over 3 times 25 raised to power 1 over 2 times 5 raised to power 0. Okay, this is 1 over 27 raised to power 2 over 3 times this is the square root of 25, and anything raised to power 0 is 1. This is 1 over the cube root of 27 raised to power 2 times this is 5 times 1, and that is 1 over cube root of 27 is 3 raised to power 2 times 5 times 1. This is 5 over 9, and that's the answer. Number 13 says we should simplify 25 raised to power minus 1 over 2 times 27 raised to power 1 over 3 plus 121 raised to power minus 1 over 2 times 625 raised to power minus 1 over 4. Okay, 25 is 5 raised to power 2 raised to power minus 1 over 2 times 27 is 3 raised to power 3 raised to power 1 over 3 plus 121 is 11 raised to power 2 raised to power minus 1 over 2 times 625 is 5 raised to power 6 to 5. Okay, let's first do this to be 1 over 6 to 5 because of this minus raised to power 1 over 4, because this is going to give us, this cancels this, will give us 5 raised to power minus 1 times 3 here, 3 there, gives us 3. Okay, plus this cancels this to give us 11 raised to power minus 1 times this is the fourth root of 6 to 5. Okay, so this is 3 over 5. You get it? 3 over 5 plus this is 1 over 11 times 1 over the fourth root of 6 to 5 is 5. Okay, so that's okay. Let's take this to the next page. 3 over 5. Now if we multiply this, we're getting 1 over 55. So we want to add it to 1 over 55. LCM is 55, 11, 33 plus 1, and that is 34 over 55, and that's the answer. Number 14 says simplify 0.8 raised to power 3 times 0.05 raised to power 2 over 0.32. Okay, 8 is 8 over 10. 0.8 is 8 over 10 raised to power 3 times this is 5 over 100 raised to power 2 over 32. 0.32 is 32 over 100. Okay, now we can cancel here to give us even if you don't cancel, you see that 8 and 32 here, so you can easily just represent it to be 8 raised to power 3 over 10 raised to power 3 times 5 raised to power 2 over 100 raised to power 2, which are these. Then divide. If I want to change it to times, this will flip 100 over 32. This has to flip, changing it to times. So we can simply strike off values. This is same thing as 8 raised to power 3 is 8 times 8 times 8. Let me write it so you see it over. This is 10 times 10 times 10 raised to power 3 times 5 times 5 over 100 times 100. 100 times 100, take note this is 100, then times 100 over 32. 100 strikes off 100 here. You see 5 times 5, 25 strikes off. 25 into 100 gives you 4. Okay, then 8 here 1, 8 here 4, right? 4 here 1, 4 here 2, so we're left with 2 times 8 over 10 times 10 times 10 times 4, and then we can still strike off values here. 4 here 1, 4 here 2, which is 2 times 2, 4 over 1000. Okay, which is simply 0.004. Okay, the next we have to look at, hope you're enjoying it, hope you understand what I'm doing. It's my desire that you enjoy it and you understand what I'm doing here. Now the next question says, if a raised to power 2, b raised to power minus 3, c, all raised to power 3 over 4 over a raised to power minus 1, b raised to power 4, c raised to power 5 is equal to a raised to power p, b raised to power q, c raised to power r. We should find the value of p plus 2q. We should find the value of this. Okay, now take the a's, the b's, group them as the case might be. So this is a raised to power 2 times 3 over 4 times b raised to power minus 3 times 3 over 4 times c raised to power 3 over 4 over a raised to power minus 1 times b raised to power 4 times c raised to power 5. Okay, so this here is 2, so that's a raised to power 3 over 2 times b raised to power minus 9 over 4 times c raised to power 3 over 4 over a. This is divided, so when we are dividing, you should know we should subtract the powers raised to power 5. So this is a, taking this divided by this, 3 over 2 minus 1 is plus 1 times b raised to power minus 9 over 4 minus 4 because of the divide times c raised to power 3 over 4. Okay, divide will be minus 5. Okay, so this is one number 1 over 2, 1.5 plus that will give you a 2.5 raised to power 2.5 times minus is going to give us minus, so b raised to power, this is 2 whole number 1 over 4, so that is minus 2 minus 6 whole number 1 over 4 times c, this is minus 4 whole number 1 over 4. Okay, so that is a raised to power 5 over 2 times b raised to power minus 25 over 4 times c raised to power minus 17 over 4 is equal to, we have to compare now, c raised to power r. Okay, now it means that p is 5 over 2 related to b, q is minus 25 over 4, and r related to c is minus 17 over 4. So p plus 2q is simply 5 over 2, which is p, plus 2 of q, 2 of this is 2, so it's 5 over 2 minus 25 over 2. LCM here is 2, 5 minus this into this 125, which is minus 20 over 2, and that's minus 10. Wow. Okay, we'll soon I'm going to indices questions, but before that, let's solve 1 or 2 questions. Simplify. Next question, simplify 3 times 2 raised by n plus 1 minus 4 into 2 raised by n minus 1 over 2 raised by n plus 1 minus 2 raised by n. Bring out all the 2 raised by n's up and down. That's just the secret. They are going to cancel themselves. So this is 3 times 2 raised by n 2 raised to the power 1 minus 4 2 raised to the power n times 2 raised to the power minus 1 over 2 raised to the power n times 2 raised to the power 1 minus 2 raised to the power n. You can see 2 raised to the power n is here, 2 raised to the power n is here. So we'll bring out 2 raised to the power n from the numerator. We'll be having 3 times 2 raised to the power 1 minus 4 times 2 raised to the power minus 1 over 2 raised to the power n here. We're left with 2 minus 1. I've brought this out. So this can take care of this. This time this is 6 minus, this is 1 over 2. 1 over 2 times that is 2 over, this is 1, which is 4 over 1, which is 4. Okay. Okay, let's begin to solve indicial equations. Okay, before indicial equations, just one more. It says simplify 6 raised to the power 2n plus 1 times 9. That's the next question. Raised to the power n times 4 raised to the power 2n over 18 raised to the power n times 2 raised to the power n times 12 raised to the power 2n. If you look critically, you have 2 3 here, 3 here, 2 here, 2 9, which is 2 3 still 2, 4 3, which is still 2 2. So you can take everything to 2 3s. So this is 2 times 3 raised to the power 2n plus 1 times 9 is 3 raised to the power 2, 4 is 2 raised to the power 2, and that gives us 2 raised to the power this, that's 4n over this is 2 times 9 raised to the power n times 2 raised to the power n times 12 is 4 times 3 raised to the power 2n. Okay, so this is 2 raised to the power 2n plus 1 times 3 raised to the power 2n plus 1, splitting this, times 3 raised to the power 2n times 2 raised to the power 4n over, this is 2 raised to the power n, 9 is 3 raised to the power 2n, okay, times 2 raised to the power n times 4 is 2 raised to the power 2, then times 2n will give you 4n times 3 raised to the power 2n. Can we cancel? Yes, this takes care of this. This takes care of that. Okay, I see we can still proceed. So it's going to give us 2 raised to the power 2n plus 1 times 3 raised to the power 2n plus 1 over 2 raised to the power n times 3 raised to the power 2n. 2 raised to the power n, so I can cancel that. So it's going to give me 2 raised to the power 2n times 2 raised to the power 1 for this times 3 raised to the power 2n times 3 raised to the power 1 over 2 raised to the power n times 3 raised to the power 2n. This cancels this, this cancels this, and we're left with 2 times 3, and that's 6. Wow. Okay, let's start solving indicial equations, exponential equations relating to indices. The question, first question under that says, if a raised by s is equal to 32, we should find s. When you have indicial equations that have indices, the simple trick there is to make both bases the same. Like if you see this 8 now is 2 raised to the power 3 s, of course, and 32 is 2 raised to the power 5. So if the bases are the same, you just compare the powers. If this is the same as this base, it means that this power must be the same as this power. Okay, so it means that 3s is equal to 5, meaning that s is equal to 5 over 3. Or simply, if the bases are the same, just cancel the bases. You'll be left with 3s is equal to 5, so s is equal to 5 over 3. Simple enough, right? Number 2, it says we should find y if 10 raised to the power y times 5 raised to the power 2y times 5 raised to the power minus 2 times 4 raised to the power y times 4 raised to the power minus 1 is equal to 1. We should look for y. Okay, now there is 2 and 5 here, 2 here and 2 here, so we'll break that down. 2 times 5 raised to the power y raised to the power y, okay, times 5 raised to the power 2y times 5 raised to the power minus 2 times 2 raised to the power 2y times 2 raised to the power minus 2 is equal to 1. Okay, so let me take the 2's. 2 raised to the power y times 2 raised to power 2y times 2 raised to power minus 2, which is this, and this. Then take the 5 raised to power y times 5 raised to power 2y times 5 raised to power minus 2 is equal to 1. Okay, times will take one base and we'll add the powers. This is 3y minus 2, then times 5. This is 3y minus 2. Wow, you can see the powers here are the same. So if they're the same, we can multiply the base to give us 10 raised to power 3y minus 2 is equal to 1. And 1 is same thing as 10 raised to power 0. Anything raised to power 0 is 1. So 10 raised to power 3y minus 2 is equal to 10 raised to power 0. This takes care of this. So 3y minus 2 is equal to 0, meaning that y is equal to 2 over 3. Okay. The next question says we should solve the simultaneous equation. Solve the simultaneous equation. 2 raised to power s plus 2y is equal to 1, and 3 raised to power 2s plus y is equal to 27. Okay, this is 2 raised to power s plus 2y is equal to 1 is 2 raised to power 0, 3 raised to power 0 is 1. And this other equation is 3 raised to power 2s plus y is equal to 27 is 3 raised to power 3. So these bases can cancel themselves, plus y is equal to 3. These bases can cancel, x plus 2y is equal to 0. Now this is equation 1, this is equation 2. So if you break that here, you see here this is s, so I can multiply equation 1 by 2. If you multiply by 2, it's going to give you 2s plus 4y is equal to 0, and 2s plus y is equal to 3. This 1 and this is 2. In Jamb, for you to be effective, quadratic equation, simultaneous equation, you shouldn't think to solve them. You shouldn't think. You can't make mistakes with those two guys. They should be too simple for you right now. Okay, so if you don't have that yet, please work on it. If we subtract this, takes care of this. This minus this is 3y is equal to minus 3, meaning that y is equal to minus 1. Okay, if we have y to be equals to minus 1, if we put it here, we can get s. So from 1, s plus 2y is equal to 0. I will know that y is equal to minus 1. So if we put it here to get s plus, in place of y, put minus 1 here, gives you minus 2 is equal to 0. So s is 2. So the values of s and y, s is 2 and y is minus 1. Okay, s is 2 and y is minus 1. Okay, the next question says we should solve simultaneously also. 27 raised to power s over 81 s plus 2y is equal to 9, equation 1. Then s plus 4y is equal to 0. So we just need to break that down. 27 is 3 raised to power 3 divided by 81 is 3 raised to power 4. Okay, 9 is what? 3 raised to power 2. So this is minus, so it's going to give us 3 raised to power 3s minus, take note, the minus is for all. 4x plus 8y is equal to 3 raised to power 2. So that's 3x minus 4x plus 8y is equal to 2. This is minus x minus 8y is equal to 2. Okay, if we bring that here now to solve simultaneously, s minus s, so we add. If I add, this is going to give me minus 4y is equal to 2. So y is minus 1 over 2. So if y is minus 1 over 2, let's put it into this guy, which is equation 2. Put it into 2. S plus 4y is equal to 1 over 2 minus, is equal to 0 rather. S plus 4y is equal to 0. So I want to put y is equal to minus 1 over 2 here. So it's going to give me s plus 4 minus 1 over 2 is equal to 0. I'm beginning to look at my time. I want to cover before this 1 hour runs out. So this is s minus 2 is equal to 0. So s is equal to 2. So the values of s, 2, and y is minus 1 over 2. That's the answer. Okay. Exponential equations also proceeds. You can also be told to solve the exponential equation 2 raised to the power 2s minus 3 into 2 raised to the power s plus 2 is equal to 0. Okay, the simple trick here is to make this 2 raised by s like this and call it a function, say p. So this is a 2 raised to the power s raised to the power 2, because this is going to give you this minus 3 2 raised to the power s plus 2 is equal to 0. Okay, this now boils down to 2 raised by s here, 2 raised by s here. So we can say let 2 raised by s be equal to p. So putting it here, I have p squared minus 3 minus 3p plus 2 is equal to 0. Okay, so this is a quadratic equation we have to solve. You multiply these terms together, I have 2p squared minus 1 times minus 2 gives you this, and this gives you this when added. So it means p is equal to, the simple way, when you get the factors, the correct factors, negate it, multiply it with negative. That's what it means. So if you negate this, you have 1. If you negate this, you have 2. Divide with the coefficient of p squared. Here is 1. So if you divide this with 1, we still get this to be the answer. So p is 1 or 2. So when p is 1, if we put 2 raised by s is equal to p, p is 1, now it means 2 raised by s is equal to 1. 2 raised by s is equal to 1 is 2 raised by 0, so s is equal to 0. Or 2 raised by s is equal to p. When p is 2, 2 raised by s is equal to 2. 2 is something as 2 raised by 1, so s is 1. So s is 0 or 1. Okay, I hope you're understanding what we're doing here. The next question says we should solve this 2 raised to power 2x plus 1 minus 9 raised to power 2x plus 4 is equal to 0. Same thing, 2 raised by s here, try to make it 2 raised by s. So you have 2 raised to power 2s times 2 raised by 1 minus 9 2 raised by s plus 4 is equal to 0. Now this is 2 raised to power s raised to power 2 times 2 raised by 1, which is 2, minus 9 2 raised by s plus 4 is equal to 0. So if you say let 2 raised by s be p, so this is p squared times 2, which is 2p squared, minus 9, this is p, plus 4. Okay, so that's the quadratic equation we have to solve now. 2p squared minus 9p plus 4 is equal to 0. Okay, is equal to 0. So solving this, we have to go this way, which is 8p squared minus 1 times minus 8 gives this, this plus this gives this. So you negate, it means p is equal to negate 1, you have 1, negate 8, you have negate minus 8, you have 8. Then after you have negated them, you divide with the coefficient of p squared. P squared in this case, the coefficient is 2, so divide by 2, divide by 2, so p is equal to 1 over 2 or 4. We said that 2 raised by s is equal to p. So when p is 1 over 2, it means 2 raised by s is equal to 1 over 2. What's 1 over 2, please? 2 raised by minus 1, so s is equal to minus 1. Then 2 raised by s is equal to p. P, when p is 4, so 2 raised by s equal to 4 is 2 raised by 2, so s is 2. So s is equal to minus 1 or 2. Okay, then look at this. We are also asked to solve 5 raised to power 2s plus 1 plus 5 raised to power 2s is equal to 150. Okay, you can see 5 raised to power 2s and 5 raised to power 2s, so you can represent it with the function, say p. So this is 5 raised to power 2s times 5 raised to power 1 plus 5 raised to power 2s is equal to 150. So we can say let 5 raised to power 2s be equal to p. So this is 5p plus 5 power 2s is p is equal to 150. Okay, this is 6p is equal to 150, meaning that p is 150 over 6. 2, 3, 5, p is 25. So if P is 25, we have already said 5 raised to the power 2s is equal to P, meaning that 5 raised to the power 2s is equal to P is what? 25. 5 raised to the power 2s is equal to 25 is 5 raised to the power 2. 2s is equal to 2. S is equal to 1. So s is equal to 1. It's the answer there. Okay? Okay, I think we have about 5 more minutes. So let's try to solve like 2 more questions if I give you what to do. We're also told to solve for the values of s, 3 raised to the power 2s minus 12 raised to the power 3 minus 12 into 3 raised to the power s times 27 is equal to 0. Okay, so you see 3 raised to the power s, so say 3 raised to the power s raised to the power 2 minus 12 into 3 raised to the power s plus 27 is equal to 0. Call this p. Let 3 raised to the power s equal to p, because you have it here, you have it here. So p squared minus 12p plus 27 is equal to 0. 27 is 9 times 3, and I need negative, so I have this time this is this plus this is this. So p is negate divided by coefficient here is 1, so p is this or this. So 3s 3 raised to the power s equal to p, meaning that 3 raised to the power s is equal to, when p is 9, 9 is 3 raised to the power 2, so s is 2, or 3 raised to the power s equal to 3, 3 raised to the power 1, s is 1 when you cancel. So s is 1 or 2. Okay, we have crossed the boundaries and we have solved questions. We have solved over 20 questions. I want to see what you can do, and I'll also tell you how you can get across to me. I'm going to give you some questions to do on your own. You can get across to me to, if you have any challenges, I'll tell you how to do that. Now, these are the first questions. Please take out time and go through it, solve it. The questions are similar to what we've been doing. These are the first 8 questions. Okay. The others you have to do. Okay. Okay. Got that? Then this is last have to do. Okay, now to follow me, it's easy. I'm on Twitter, I'm on Instagram, I'm on Facebook. Just search for Jeremiah Ajali. You see me, and follow me. I'll be discussing more about Jamb 2018, preparing you for 2018. So just search for these in any of those forums and follow me. But more importantly, I have a class, an online class on WhatsApp. We discuss various topics, various questions. We just get ourselves ready for the exams. 080373360005. That's my WhatsApp number. Okay. To join the group, because I want to select serious students, those really serious to learn, I am not opening the group for everybody. I'm making it relatively private, and it's going to cost you a little to join, just a little. I'm trying to create a bottleneck, so I want to select those that are serious to learn and follow me. Okay, so it's very simple. You contact me on that WhatsApp number, and you are to pay just the sum of 2,000 naira. You pay the sum of 2,000 naira to my GTB account. This is it, 00314352289. You can tell your dad to do that for you. You can transfer, and I will also receive it. That's the name you see. Ajali is a, and it's a GTB account. Okay, so you pay the sum of 2,000 naira to the account, and I'll add you to the WhatsApp group. We discuss much there. Students, your co-students, you'll be seeing people in your school, the same course and all that. Hopefully people you'll be seeing in your school. Okay, so this is about 1 hour since we have been studying. I couldn't finish up indices and logarithm, only did indices, meaning that I have to do logarithm in the next video. But before the next video, I'd like to know what you think, or like to know how you see what I'm doing here. Comments, I'd like to see your comments. I like those responses. It's encouraging when I know that you are watching over there. So tell me what you think. Please subscribe to my YouTube channel. These videos will be available there. I'll be including other videos so you can follow me and learn more. I'll be doing other subjects as time goes on, but for now, like I said, it will just be mathematics, Jamb maths. With time, I'll go into physics and chemistry. I'm just looking at time basically, because I can actually do physics, chemistry, and maths very well. So for now, this is all we can do on indices. The next video is going to be number logarithm before we go through the other 10 topics. So thanks so much for watching. Don't forget, I'm expecting to see you in my WhatsApp group. I will prefer you sending messages than calling, because I'm a busy man, and I respond more to messages whenever I see them. So I'll prefer you sending messages than calling. Once more, thank you. See you next video.